Okay, I have to just say 2 more words because I just realized that I forgot to start it again. I only missed this. Okay, just 1 minute, 1 minute. So this is the limit of x when x approaches infinity from this. This is not, it's a function raised to a function. First step, we have to denote this function by y. We have to apply the limit operator to both sides and bring down 1 over x. And then we apply the natural log operator first, and then the limit operator. And now I check. And the top goes to, good. The bottom goes to, awesome. So it's a piece of cake then in comparison to almost everything else, right? So limit as x approaches infinity, similar to this. So this is 1 over e to the x plus x, and in parentheses, e to the x plus 1 over, very good. So now I would rewrite as limit as x approaches infinity from e to the x plus 1 over e to the x plus x. The top goes to, good. The bottom goes to, good. So then again, limit as x approaches infinity. The top is, the bottom is, good. Still infinity over infinity. So limit as x approaches infinity from the top, and the bottom is, good. Now I don't have to do anything because these two go away, and the answer is 1. Now I have to copy the starting point and the end point. So I will copy limit of natural log y. Yes, limit of natural log y as x approaches infinity is 1. Then I'm allowed to swap the operators. So I will have natural log of limit as x approaches infinity of y equals 1. So at this point, I'm asking myself, what could this be?
0.
Natural log of 0 doesn't exist, so it must be, yes. Very good. So then the answer for this is, is this okay? Is this okay?
Finish. I feel like we finished the notation right there. So it's the limit as x approaches infinity.
Natural log y. I swap the operators. Natural log goes in front. Limit of the function. So this number must be e because only natural log e is 1.
Okay. Oh, right. We have to substitute back
Yes.
the full function.
Yes. Yes. And then that's why I was lazy and I went back and I put e up here. Any questions on this? Okay. So graph the function showing everything that is relevant here, and the function is 2 the square root of x minus x. So let's work on that. Yes.
What's end behavior?
And behavior is if it has a horizontal asymptote or not, or if it has a slant asymptote or not, or if it opens upward, goes to infinity. When x approaches infinity or negative infinity, what does the function do? That's the end behavior. Let me know if you need help, please. Can we start working on it together for a minute and then I'll let you continue a little bit? Okay. So what is my starting point? Because I'd like to finish this in the next 20 minutes. Yes, awesome. I have to state the domain first. So, say it again. Yes, very good. This is defined everywhere, but this is not. So it requires greater than or equal to 0. Therefore, the domain is 0 to infinity. Awesome. So that will be my starting point, in which I put in f prime, f, and the second derivative. And it has to be 0 to infinity. Indeed, that's my starting point, the domain, and then the table. Now, what else can I find about the function from the function itself? No, from the function itself, not yet. So first of all, I have to plug in 0. Yes, and I have to plug in infinity. So I have, I shouldn't say plug in, but I have to find the limit. So I have to find the limit of 2 the square root of x minus x as x approaches infinity, because I need to put something here. Yes, because one of these two is much smaller than the other. Which of these two quantities is the smallest, the first or the second? The first. Yes. So this is too small because I have to take the square root. So this will cover everything. Indeed, so this is negative infinity. So first I need to see what happens at 0. Then I have to see the end behavior, which in this case is negative infinity. And now I have to find x-intercepts. I found a y-intercept already. I plugged in 0. But I have to find x-intercepts. So how do I find the x-intercepts for this function or any function? Set the function equal to 0. Very good. F of x equals 0, which is 2 the square root of x minus x equals 0. Be very careful because this is not an absolute trivial problem, right? If you say square, it's going to be a mistake because I can't get rid of it. When I square the left-hand side, I have 3 terms, and one of them will still have a square root in it. So I have to separate the terms because it's a radical equation with only one radical. So this term has to go to the other side. So then 2 the square root of x equals x. How do I continue? Now obviously I have to get rid of the square root. And now I will do what? Yes, now I can square both sides. And I get 4x equals x squared. I have to get 2 solutions because it's quadratic. So this is x squared minus 4x equals 0. I factor out x. I get x minus 4. So I get 2 solutions. I already have one, but I have to plug in the other. Only now I can say I exhausted everything that I can find about the function from the function itself. So x and y intercepts and behavior, limits. I'm done with the function itself. Only now I can move on to the first derivative. So let's move on to and work on the first derivative now. Is it clear? So please remember solving the radical equation. We have to separate the radical from the rest. Hopefully we only have one radical in the equation. Because if we have 2, then we have no choice. We have to have, if we have 2 radicals and another term. So far so good? Okay, so now you're going to determine what? Perfect. Okay, so when you're ready with the derivative, let me know. So 2, 1 over 2 the square root of x, and then minus 1. Remember, it's 1 minus the square root of x over the square root of x. This is extremely important to change it into a ratio. Yes, I will factor out negative 1, negative the square root of x minus 1 over the square root of x. So I look at f prime. What am I trying to find now? Critical numbers. In this case, critical numbers come from 2 sources. Yes, very good. So when x is 0, f prime is undefined where the function is defined. So if the first derivative is undefined, any other will be at that point for sure. Okay, so now the other source will be for the square root of x minus 1 to be 0. Yes, the square root of x equals 1, I square and I get x equals 1. So 1 and 0. Now I have to study the sign of the first derivative. Okay, so let's say I study the sign on this. It doesn't matter which one. So let's say 0.5. The square root of 0.5, 1 minus the square root of 0.5, the sign, positive. And the denominator is square root of 0.5. So then positive over positive is good. Let's plug in 10 or 9. 1 minus the square root of 9 over the square root of 9. Yes, indeed, because the top is negative and the bottom is positive. At this point, I have to figure out this y value. This is my next point, next step. So 2 minus 1 is 1. Now I exhausted the first derivative, but it's not enough before I make sure that these two rows work together, because otherwise I shouldn't continue. I should go back and fix my mistakes. Okay, so let's do this. From 0 to 1. Supported by the sign. From 1 to 0. Supported by the sign of the first derivative, and then decreasing. Perfect. Only now I can say that 1 comma 1 is what? Local max. It could even be the absolute. We can figure that out later. Okay, now what? Yes. But obviously, I will differentiate this form, not this form, not this form. So the first derivative that I'm looking at is x to negative 1/2 minus 1. This is what I want to differentiate. Not the ratio and not the ratio. So then the second derivative, negative 1 over 2, x2, very good. And this is negative 1 over 2 square root of x cubed. Perfect. Since the second derivative is or is never 0? Is 0 or never 0?
Never 0.
Never 0, because it's a fraction and the numerator is 1. So this will never be 0. I only need to study the sign. Remember the domain of the function. So what type of number will always this? Will this always be? But since it has a negative in front, the second derivative will always be negative, which means, obviously, that the function will always open downward. The concavity is opening downward. Yes. So now I'm ready to graph this function. Any questions before we continue? So overall, not a difficult situation, but I wouldn't say that's super trivial either, right? So let's graph the function. So I will plot 0, 0. I will plot 1, 1, 2, 3, 4. And then this says from 0, 0, increasing, opening downward to 1, 1, and then decreasing, opening downward to crossing the x-axis at 4, 0 and going towards negative infinity. So this is the graph of f of x equals to the square root of x minus x. Say it again.
1, 1, then a global max.
Yes, it has a local max, and now we can also guarantee that this is a global max. Local, global, max. Perfect. There is no global minimum unless I can name it. There is no global min, because I can name it. Okay, very good. Okay, so we are looking at 3 more problems, so let's take a look. We did this problem in class. If you want us to do it again, we can.
Yes.
That's fine. So we have 1,200 squared centimeters of material is available to make a box with a square base. Square base, x, 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 and y. An open top. Find the largest possible volume of the box. Can anyone let us know how to start? Yes, which one? Volume? Okay, good. So x squared times y, very good. What else? I cannot differentiate a function with two variables. Not in this class. The derivatives will be partial derivatives. They will not be denoted by d, but this d. So we can do that in this class. Yes. So I have to write the area, which is 1200, which is?
X squared.
Yes. Plus 4xy. Very good. So till I get rid of one of the variables, I will not be able to differentiate because these are not related rates. V, x, and y are not functions of time, so we can differentiate.
You can make x squared equal negative 4x.
I don't want that because that will be very complicated.
Oh, yeah.
So I would like to eliminate y. So I will solve this equation for y. So 4xy equals negative x squared plus 1200. So y equals negative x squared over 4x plus 1200 over 4x. You can say, why didn't you just write a long fraction line over 4x? Because I like to simplify each fraction. So the first one simplifies into negative x over 4, and the other one into 300 over x. Are you with me so far? Is that a yes? Okay. So now I put it back here. I take all this and put it here by multiplying by x squared. And multiply by x squared. So then the volume now is a function of x indeed. So this times x squared will be negative x cubed over 4 plus this times x squared will be 300x. Is this okay? Now we can differentiate. We have a function of x, one variable only. So v prime, I don't know what I wrote there. Nobody knows. Sorry. So v prime of x is negative 3x squared over 4 plus 300. Remember, this is very important to change it into a ratio. Negative 3x squared plus 1200 over 4. We're adding fractions that do not have the same denominator. We have to find the least common denominator. So then I set this equal to 0. And then the numerator, negative 3x squared plus 1200 equals 0. Or x squared equals 400. We move 1200 and divide by negative 3. We get x squared equals 400. And we take the square root. We should correctly write plus or minus 20, but then wake up and say no, only 20. And what was it? What was the measurement unit? Very good. So we can determine the y from here. 20 over 4 with minus in front is negative 5. And this is 15. So this is 10. So one more time, 20 over 4 is negative 5. And then 15, yes. So now I still have to show that 20 gives a maximum. I'm not certain yet. But when I study the sign of the first derivative, at 0, this is 300. So what is the sign to the left of 20? Very good. Now let's plug in 100. 100 squared, 10,000 times negative 3 is a big negative, plus 1,200, still negative over 4. So this is typical for a maximum. Now, if I'm asked to find the maximum, then I have to plug in 20 and 10 in the volume. So if I want the maximum volume, I will have x squared, which is 20 squared, times 10, which is y. So 4,000 cubic centimeters. Any questions?
How'd you get that y was 10?
By plugging in here. So 20 divided by 4 with minus in front will be negative 5. And 300 divided by 20 is 15. So negative 5 plus 15 will be 10. Is that better? Okay, one more problem and then the extra credit. Find any root of the equation using 6 decimal places. Just one. I only need one. You don't have to repeat the process to find all of them. I only care about one. Now, I would like you to try to finish your checklist by Wednesday so you can ask questions. You will turn it in on Monday if that's what you want. I'm fine. But if you don't look at all problems, you're not going to know what to ask before you turn it in on Monday. Okay, so just at least attempt each problem. And let me know if you have difficulties with any of them. So here we have 2 cosine x equals negative x minus 1. And let's work on this and find any solution with 6 decimal places. So 2 cosine x plus 1 equals 0. That's our function. Remember, I recommend creating the table, the function that is Newton's method. So you can quickly determine the iterations. And yes, you have to plug it in to check, to find an interval, right? Where the function is continuous and changes sign by the intermediate value theorem. And then, yes, Nico? Yes, negative 2 to negative 1. And you start anywhere you want. You can start at negative 1 or start at negative 2. It's up to you. Now, if you start at negative 2, you may, the method will converge in 2 steps. If I start at negative 1, you may converge in 3. And that's not a big deal. But we will both get to the same answer. Say it again. The intermediate value theorem. So you put in the function in the graphing calculator. So yes, perfect. So now let's go to second table and plug in negative 3, negative 1. You already graphed it, so you have an idea where they, yeah.
So I just want that.
You want where it crosses the x-axis, correct? You're trying to find the x-intercepts. We're trying to solve the equation. So I see it as between -2 and -1. So you can either start with -1 or start with -2. It's up to you. As x0. But you have to write, don't forget to write Newton's method, right? So this is our function, 2 cosine x plus 1. F prime is -2 sine x plus 1. And remember, g of x is x minus f of x over f prime of x. And all I have to do is just plug them in. So it's x minus 2 cosine x plus 1 over -2 sine x plus 1. And this is the function that will give us all the iterations. Bless you. But of course, I jumped a few steps, and I shouldn't. I should say, okay, this is a function that is continuous and differentiable. I don't need differentiability, I'm sorry. This function is continuous, and it changes sign between -2 and -1. Therefore, there must be a solution by the intermediate value theorem. There must be a solution between -2 and -1. Yes, please.
You forgot an x, didn't you?
Yes, of course. Thank you so much. Thank you. My apologies. So let me go back and write those steps. So I have to write that f of -2 is less than 0. I have to write that f of -1 is greater than 0. And f is continuous on the interval -2, comma -1. Therefore, by the intermediate value theorem, I will find a number c in the interval -2, -1 such that f of c is 0. Then I create Newton's method as a function that I will be putting in the graphing calculator. So, are you there yet, or you want me to wait?
Wait 1 minute, please.
Ready? Ready? Okay, so in y equals, clear everything and put in x minus, don't forget parentheses for the top, 2 cosine x plus 1, 2 cosine x, close the parenthesis, plus x plus 1, close the parenthesis, divide by, close, open a parenthesis, -2 sine x plus 1, -2 sine x, close the parenthesis for sine x, plus 1, close the parenthesis for the denominator. Make sure that you are in radian mode. Make sure that the mode is in radian. Okay, so, and then, go second and quit. I go to variables, and then I go to functions, and I call function y1. Now you tell me where do you want to start? And you have to put it on paper. x0 is blah. Okay, so we want to start with x0 equals -2, and we will determine what after I plug in -2 in this function. What is this?
How do you pull that again? The y1?
So you go to variables. Go to variables to the right, and then function, call function y1. Okay, are you with me, everyone? So what is this number? -1.3499265. I need to copy 7 digits. If I want 6 digits, I need 7. What is this number?
0.
X0, we chose it. We don't calculate x0, we choose x0. So this is the first iteration. It's a better approximation of the real solution than -2 was, for sure. Okay, then I go second end entry, but this time I override the -2 by the previous answer. And make sure you delete everything else. So now it's y1 of the previous answer, which in this case is -1.34, blah, blah, blah. So I press enter. And this is now x2, which is -1.3798207. Make sure you copy 7 digits. And then all I have to do is just copy again. Okay, -1.3797657. This is x3, -1.3797576. If the next iteration has the same 6 digits, I don't have to copy the next one. 1, 2, 3, 4, 5, 6. I don't care for this one. It's identical. So the answer is 246. That's all I want. If you want to round it up, you can. But this is the final answer. And the method converged in 3 steps. We chose x0, and in 3 steps it converged to 6 decimal. Any questions? Does it make sense? But we couldn't do this in pre-calc or algebra because we did not have all the information. We didn't know what derivatives were, but now we have this awesome tool. So here's an extra credit. Verify that the function increases at the maximum rate when y equals L over 2, and you must prove why. Okay, so let's, yes, please. Go ahead.
Can I just, work this thing?
Okay, so we have a function. Let's copy it. We are told that lowercase a, lowercase b, and uppercase L are all positive numbers. So you don't have to worry about those. Furthermore, we are told that we have a function f of x, which is very clear. What does that mean? Which means that there is only one variable, and that variable must be
X.
that's it. Everything else should be disregarded in the sense that, Ellie, are you fine? Done?
Yes.
Okay, thank you. Okay, so it says that the function increases at the maximum rate when y equals L over 2. Oh, sorry. Sorry. Sorry about that. There's no y in this problem. The function is a function of x, not of y. Okay, so let's take a look. First, I will get it prepped. I don't want this. I want this. But that's me. I mean, you don't have to. If you're comfortable, if you prefer a different route, that's fine too. So, of course, I have to find f prime. I bring down -1. 1 plus a e to negative x over a raised to
X over B, and then
it's very interesting when somebody cannot read her own handwriting, right?
It is very.
Very interesting. Yes. Thank you so much. My apologies. So I bring down -1. I multiply by L, and now the power becomes -2, and now I have to differentiate inside. 1 is a constant, it goes away. A is a constant but stays. I have e to negative x over b, and multiplied by -1 over, exactly, in parentheses, -1 over b, parenthesis, and another parenthesis. Okay, I have to clean this up. I cannot even look at it. It hurts my eyes. Okay, so in A with -1/b and with a -L. I agree. So this is AL over B. Yes, this piece and this piece and this piece, they all go in front. Now, this is 1 over e to x over b and 1 plus a e to -x over b squared. Okay. Any questions on the derivative? I know I have 3 minutes left. I'll try to finish. If not, we can finish it on Wednesday. So let's make sure that this is clear. Do we understand the derivative? Okay, let's do this again. I change it into a product. I had L, and all this quantity becomes gets power -1. Agreed so far? Okay, I'm differentiating with respect to x. So L times the quantity to -1. When I differentiate it, I bring down -1, I multiply it by, I put it in front of L. And then this function to -1 minus 1, which will be -2. And now I have to differentiate this function, the inner function prime. This prime is 0. This will not be differentiated because it's a constant. So e to u prime is e to u times u prime. U prime is -1 over b. These are all products except this, right? But these are all products. So I can multiply -L by a by -1 over b. Sorry about that. Okay, so then -L with a and the -1 over b go in front. A is at the top, L is at the top, but b is in the denominator. So this is a multiplication product, right? Now this has power -2, it will go to the denominator. This has e to -x over b, has power -x over b, so it goes to the denominator. Okay, so we are told that a, b, and L are positive numbers, so all this is positive. Now what can you say? What can you say about this quantity? It's always positive. Very good. So what can you say about the function? It will always be increasing. So the function will always be increasing. Okay, good. So now I would like you to think, I know I only have half a minute, but I would like you to think of this. So there is a function that is always increasing. I would like to determine where it's decreasing the fastest. I'm not asking about max min. There is no such thing. The minimum is at whatever, and the maximum is at whatever. So I'm not asking about finding max or min, so I'm not going to set this equal to 0. But what will tell me where this function is increasing the fastest? The function f of x. Second derivative. So please calculate the second derivative, and we'll discuss about it on Wednesday. Yeah. Very good.
The second derivative